This morning's presentation is on the principles of decentralized cyber infrastructure and distributing cyber risk. It's something I've been trying to understand for a long time, and so I'm going to do my best to articulate what I think I understand, but I'm not sure I do. So we'll see how this goes. Okay, so a little bit about my background and how my train of thought has come to be what it is today. So I have a background in physics, not particularly talented at that, so I went into teaching high school for a few years and learned a lot of things. I think I learned more teaching high school than I taught. And then I worked for a couple of Silicon Valley companies here in the Bay Area. So it's been a long time since I've been back. But it's good to be back. And then I moved to Alaska in 2002. Worked for the satellite facility, and then I spent about the last 13 years at the College of Fisheries and Ocean Sciences with a focus on the IT systems for the RVs at Kuliak as part of the U.S. academic research fleet. And then most recently, within the last couple of months, I've moved on to Alaska Center for Energy and Power. So I'm going to share with you a few perspectives that I have. From a physics perspective, I've been trying to understand a lot of concepts for a long time. And I guess I'll just kind of summarize it as I think we think about space and time wrong, and we have to think of them as emergent phenomenon. Don't know that for a fact, but the long process of trying to understand this looks at many different perspectives of trying to understand the same concepts. And my best guess today is that natural processes are iterative, fractal in nature, and emergent and relational. And so I think our cyber infrastructure also needs to be that. Having worked on a research vessel for 10 years in the Arctic, I have a couple perspectives on how to do IT services because the vessel can be away from shore 30 to 45 days. We have to have spare parts for everything on board because we can't just RMA something to the ship in the middle of the Arctic Ocean. Internet is shared by 46 people. When we started in 2013, we had half a megabit for 46 people. Getting remote access to the ship was very difficult. It's matured a lot in 10 years. And in 2023, we started out with 20 megabits. And as of August, we had Starlink. And so we had a 100 megabit connection down. So the landscape's changing. It's great right now. That could change too, though. And the vessel can operate above latitude 82. Most of our SATCOMs are geosynchronous. And as you may or may not know, when you go above latitude 82, those satellites fall below the horizon. So we lose internet connection at those high latitudes. So my basis for doing IT on board the ship has always been anything that's mission critical has to operate locally on the ship. Okay, I got to have everything local. Cloud services don't work so great without internet. Living in Alaska, so I've lived in Alaska for 20 some years, and at minus 20 or colder, cars don't generally start unless you have them plugged in with an engine block heater. Just driving into work when it's 20, 30, 40 below, if your car breaks down on the side of the road, if you don't have the correct gear, you can freeze to death just driving into work. So you have to prepare. You have to have winter gear, a sleeping bag, something to stay warm, a way to start a fire. Without power in Alaska, most people can't heat their homes. Most of our homes are, oil heat that depend on a furnace that runs with power. And we deal with a lot of natural disasters. We have extreme cold, we have wildfires, earthquakes, melting permafrost, coastal erosion, melting glaciers, and I forgot to add volcanoes. So Alaskans value self-sufficiency. They value being prepared and being adaptable and keeping our options open. And then the last perspective is on the concept of trust. If anybody's read Noah Harari's book, Sapiens, A Brief History of Humankind, a lot of this perspective comes from that book. But the idea is generally that humans what our superpower is we've generalized collaborative trust. So we work together collaboratively, and this requires building trust. With individuals, that takes time and effort and energy, and it's hard. So somewhere along the line, we learned how to abstract trust in what are called shared myths. And so we don't have to build trust in each other as long as we all share trust in the myth. And so that's allowed us to accelerate collaborative trust across large numbers of people without even knowing who they are. And I think we are starting to see the infancy of what I would call algorithmic trust, or maybe something that's anti-fragile. I'm thinking specifically of things like blockchain. The information that's stored in a blockchain is highly trustable, I think. Um, and and I think this is important because I think one of the problems with AI and one of the things we struggle with is we don't have a common basis for building trust between humans and AI. And I think we need a way to establish those trust relationships. The institutional trust models that we use for humans aren't going to work with AIs. Okay, so another data point. I know I feel like I'm all over the place here. I promise I'm going to try to bring it back together. So this summer in Alaska, we had a fiber optic cable that provides internet service for the coast of northwestern Alaska get cut by some sea ice. It was buried about 10 feet below the seafloor, and the ice occlusion cut it. And so for three or so months, these communities up here on the West Coast were without that internet, which means they didn't have cell services, they didn't have anything. So Kuliak pulled into Nome, Alaska, and we have more internet than the town. And we had people coming to the ship to get internet that were there. And I was just in Kotzebue, Alaska, back a couple weeks ago, and they just got things back. So a lot of Starlinks have been being installed up there this summer. Okay, so the whole point of that is, well, the whole point of that example is there's really no good reason why those communication services need to be down. We all have cell phones with radios. Why can't they just talk to each other? Why do we have to go out over this network all the way back down to have that communication come back? Okay, so that is a lesson that I've always wondered about, and there are good reasons, or there are bad reasons, I think, why that is the case today. But then I'm also aware of geomagnetic storms. Living in Alaska, I'm aware of space weather, and we see auroras frequently. They're not uncommon. I don't know how many people here are aware of something called a Carrington event. There was a very large-scale geomagnetic storm in 1859. We think these happen about every 150 years. You can do the math. We're in the middle of a sunspot maximum right now. We're peaks. It's an 11-year cycle. And so this could actually happen tomorrow. We could have a really big solar storm like this, and the impacts of which we don't really know, because back in 1859, the only major technology that was impacted was telegraphs. And today, the risk is to the electric power transmission grid. If we don't, we have a maybe 12-hour warning when we know this is coming. If we don't get the transformers disconnected from the power grid, it can blow them, and there's a very long lead time to getting those fixed. It could be years. So the world could have a major power transmission problem all across the globe. It can also impact satellites, take satellites out. This could be a major big problem for us, and I don't think we're prepared to deal with it. Now, I don't mean to be Chicken Little. Maybe it'll happen and we'll be fine, but we're extremely dependent on centralized technologies these days. And so I worry about that. There's another type of event I found out about recently called a Miyake event. These are about 10x the intensity of Carrington events. We don't know the frequency that they happen, maybe between 400 to 2,400 years. We know about them from carbon-14 datings and tree rings. That they happen. They last for maybe 10 years, so they're a much longer lasting event. And they're very intense. So it has to do with the impact of like a radiation or a solar wind. So they're very big, and we don't have any idea what causes them. We think they're interstellar. So we don't think they're solar related, but we don't know where they come from. Maybe supernovas, not really sure. So we don't know about those things. And our current technology that we built everything on in the past 100 or so years hasn't been tested against these events. Okay. So my question is, how would we recover cyber infrastructure without a power grid, without the internet, without time sources, software repositories, app stores, cloud services, and authentication services? And without those things, how will we provide goods and services, food supply chains, emergency services, medical services, and so on? All right, so my proposition is that wide-scale disaster events, global disaster events, will need decentralized cyber infrastructure to recover. We need to be able to build local networks with key basic services for society to function. So I've defined what I think I want to just call least common denominator cyber infrastructure. And this is a subset of cyber infrastructure that all members of society need in order to function. And I'm going to kind of move ahead because I want to stay on time. We want all persons to have access to this. We're going to talk about something called permissionless access, and then resiliency and data integrity are all part and scope for what I think this least common denominator cyber infrastructure needs to have. And just to talk a little bit about centralized versus decentralized. In a centralized system functions depend on a single point of authorization. In a decentralized system, there's many points. These diagrams are approximate. They're not exactly how I think about this, but it's kind of the quickest thing I found on the internet to show it. And then there's also the concept of distributed. And distributed systems can be decentralized or centralized. DNS is distributed, but I wouldn't necessarily consider it highly decentralized. So whole idea is to distribute risk. So when I think of something like I want to get my files, I don't want to have to go out to a file server to get it. I want the files to be distributed across a lot of nodes, hopefully as close to me as possible. So if I'm thinking about a local area network, all the nodes on the network could also provide file share services in part. So if one of those systems gets taken out, it's kind of like the predator-prey relationship. You have security in numbers. The file's still there. It's replicated across many nodes. So unless everything gets taken out, you don't lose your data, and you still have access, and everything keeps working. So I'm taking some lessons from nature here. I think evolution has solved a lot of these problems already. Okay, so the principles of cyber infrastructure, as best I've been able to summarize, this is being a physicist, I like to think of everything in terms of a very few concepts. This is way too many concepts. And I probably haven't got everything here. It's probably a bigger list that I then need to trim down. So, but these are them, and I'm going to go through each one. So 0 single points of dependency. So if you have a single point of dependency, that your system is centralized. It's not decentralized. They're easy targets for attack. In order to maximize resiliency, we must minimize dependency. But it's not possible to eliminate dependencies. We're always going to have some dependencies. This has a lot of parallels to 0 single point of failure in systems engineering. Platform independence, 0 vendor lock-in, and right to repair. I think these are important principles that this cyber infrastructure has to have. It should function across all platforms. It shouldn't matter what, if you're Windows, Mac, Linux, or something else. Permissive open source licensing and self-replicating software. So I don't think you should need to have to go to a centralized app store to get your data or get your updates. I think we need a peer-to-peer network with cryptographically signed directed acyclic graph type distributed hash table database of updates that you can get software updates from. I think software needs to be self-replicating. So if you're running an application, you already have everything that somebody else would need to create an instance of that software. So you should be able to serve that out. And then I think for the least common denominator cyber infrastructure, it should be a non-restrictive open source license like MIT, ISC, or BSD. Identity management. I think this needs to be decentralized. We need to have decentralized digital identities. People need to own their identities. Service providers cannot be the identity provider. That creates a conflict of interest. We need checks and balances. So I think I'll also make the argument that control of access to a resource is equivalent to ownership, and people shouldn't own people's IDs. It's not legal to own a person. I don't think we should have other companies or things owning IDs. I think people should have control of their own identities. Permissionless, like sidewalks, access to LCDCI must be open to everyone. So access must be free of gatekeepers. And I think this also means it needs to be cross-cultural and multilingual. There shouldn't be barriers to entry, or very minimal barriers to entry for people to have access. So I think in this network that I kind of alluded to, we want to have compute and storage local first if possible. And then if we don't have local things, we can reach out to get copies of information. There's a system out there called the Interplanetary File System. You may have heard of it. they've done a lot of work on this problem already. I think, and they also have a decentralized naming service called IPNS that helps solve some of the naming service problems, decentralized. Time and centralized independent security protocols. So this is one I would love to have some talks with people about because I might be wrong about it. But some of our security protocols, like SSL certificates, have time dependencies. And if we lose time, we won't be able to use those security protocols to secure sites. So I also think we need to think about time differently. Time is relative, it's not absolute, but all of our time systems that synchronize clocks think of time as linear time, which is mostly true for us here on Earth. But technically it's not true. And I think we need to think about time better and think about time synchronization and keeping time better. And I think our security protocols should be independent of time synchronization. Microgrid power generation and transmission. So in my new role at the Alaska Center for Energy and Power, this is near and dear to my heart. We're studying a lot of renewable energy and how to integrate those systems in microgrids. But you can't have centralized power dependencies if you're going to have systems work in a situation like this and be able to recover. Okay, so the last thing I think we need is also like the Svalbard seed cache, if folks are familiar with that. I think we need CI caches. We need to build caches of CI equipment, especially for disaster scenarios where we're ready to deploy, basic communication cyber infrastructure in communities. You have to be prepared. I don't know how to solve the silicon problem. I can't. We're not talking about mining chips here and the complete supply chain for technology. So I think we're going to have to cache some of that eventually. So the next step, the thing I would like to do is actually build a principles of decentralized cyber infrastructure certification so that we can start classifying technologies to see how they score on these criteria. And I would like for that system to be itself PODCI compliant. So with that, I've got about 8 minutes left for questions. Okay. Okay.
Thanks, John. So in your approach to looking at vendors that fit these criteria, even in the advance of having a certification system, what sort of technologies have you found are more already doing this sort of thing? Are there any? And in terms of implementation, can you sort of build a full infrastructure stack using these technologies now, or does it have to be sort of pieced together from things that fit into this mold and things that maybe you have to build yourself?
Okay, so I think the question is, what technologies have I found that are in line with this line of thinking? Static HTML, everything you need right there. In fact, this presentation was built in a single markdown file and is a static HTML. Other than the images that are included, those are separate additions, but otherwise it's a single file. So I've been struggling with that. I do a lot of Node.js programming. I kind of like that ecosystem, but of course there's a lot of NPM dependencies, package dependencies like every other language. What I've wanted to do, and somebody else has supposedly done this, is use IPFS, the Interplanetary File System, to be an NPM cache so that you can actually have access to all your NPMs locally. They're cached. If things get updated, they get updated. So building things like that supply chain dependency locally on an IPFS, shared network. And I would actually say IPFS itself is along these lines. So the idea is that when you build a local decentralized network, it can attach and detach from bigger networks and then eventually consistently sync. So there's a lot of things there. There's a lot of folks in I'll just say the crypto industry that are doing some interesting things. There's Atala Prism, which is built on Cardano, that is focusing on the digital identity problem, the self-sovereign digital identity problem. That's one I'm also interested in. So there's a lot of people working on similar things like this. I will say I'm a little disappointed in the Web3 effort, which is kind of along these lines, but I don't think they've quite nailed it. And I think they're missing some of these principles. So I'm not a big fan of a lot of what's happened there, and it's kind of been a train wreck, in my opinion. So, yep.
Hi, as a cybersecurity educator, as soon as you said something about certification, my ears really pricked up. So question, it's kind of a couple questions. Who would you certify? What roles? And why don't you create a micro-credential in Alaska in your EDU system?
Well, I might if I can get my employer to think of it as part of my job. But because I'm interested in doing that. But actually, I want the certification. What I want to do is build a network of kind of a reputation-based network of trust. So you can build reputations that are trustable, and have the information about what is certified in the network, kind of like things that there's. So in a blockchain, you have what's called a consensus algorithm to figure out what is allowed in the blockchain or not. So when you enter something in, we want to have a reliable algorithm for doing that, not just my opinion or somebody else's opinion. So that's what I would like to see the certification be.
Yeah, I have a question. As a mostly non-technical person, I know at least some of the current more decentralized technologies are often much more complicated than the sort of, the conventional approach. Do you think that that is intrinsic to a more decentralized approach where everyone basically needs to be more tech literate in order to effectively engage with it? Or do you think that that would be a problem that would be solved if we embraced all the principles and went down that path?
So barrier to adoption would be a real problem. I think that there's no technical reason why barrier to using the system should be as easy as using Zoom. And so I don't think that, I mean, that should be a goal to make it accessible to everybody. The idea is that it is readily accessible to a wide group of people, not that you have to have a technical barrier. Today, that's definitely the case. But I don't think that should be the end goal. I believe the end goal is to make it easy to use. Yes.
Nations. The Israeli ambassador to the UN isn't even speaking.
I hear somebody talking. I'm not sure.
That sounded like a BBC
Okay.
presenter.
Yeah, hi. Could you please say a little bit more about the decentralized identifiers? You mentioned something a moment ago, but I didn't quite catch what it was. And I'm wondering if you've looked at or are working with any of the W3C work on decentralized identifiers.
I'm not working with anybody right now. These are just my ideas. Let's see, where was my identity? Decentralized identities. No, but I think some of those ideas are along the same lines. They're trying to create what are called DIDs, DIDs, decentralized identities. And I did mention Atala Prism is one group that's looking at doing this on the Cardano blockchain. And they've had they're trying to actually pilot this in, I think, Ethiopia, where they're trying to create national identities for people that don't have a system for that. And so they're looking for places that don't have resources and infrastructure just to start this. So that's about all I know about that. But if you want to talk later, if you've got some information about that, that would be great. I'd love to learn.
Great. Thank you.